Hey guys, so today I'm going to go through the review for your solving polynomials tests. The first 4 questions are going to be on the solving part. Second 4 are going to be on writing polynomials from given zeros. And then there's 2 word problems. Okay, and your test is going to be very similar, exact same layout and breakdown as you see here. So for 1 through 4, you do need Desmos. You need to have the graphing calculator available for you so you can graph and come up with the solutions or help you come up with the solutions. So first thing it's going to ask you is the number of complex zeros. So I know based off my fundamental theorem of algebra, I'm going to have 5 zeros. Now, whether they are all real or imaginary or whatever the breakdown may be, I need my graph for that. So I'm going to pull in my graphing calculator. I can see clearly I have a -5, and then the others are all decimals. So I'm most likely going to have some radicals within my solution. But I do have that -5. That's a whole value, which will be very helpful and beneficial as I go through this. So I'm going to write that down. I do know there are 5 real. And from the graph, I was able to pull x equals -5. So I'm going to use the -5 in my synthetic division, and hopefully it gets me to a point where I can factor, because that is part of it. You don't have to factor my remainder. So let's say I have 1, 5, -8, -40. Remember, anything missing, make sure you put those zeros as your placeholders. Okay. We're going to go through our synthetic division, drop the 1 down, multiply, add, drop that down. And there we go. All right, so since I know there's no other real values that I can use for synthetic division because they weren't whole, I got to write out, remember -5 comes from a +5. This drops down a degree. So x to the 4th minus 8x squared plus 15. I can factor that. Factors of 15 that add to a -8 are a -3 and a -5. I can split that x to the 4th evenly to an x squared and an x squared. So here are my values. Again, I know that x plus 5 is where x equals -5 came from. The other 2, I'm just going to set equal to 0 and solve. So x squared minus 3 equals 0, and x squared minus 5 equals 0. These are easy enough to do. Add and then square root. So we have plus or minus the square root of 3, and you're going to have plus or minus the square root of 5. So I'm going to ask you 3 things about this problem. I'm going to ask you for how many real solutions there's going to be. I'm going to ask you for the final factored form and for your zeros. Okay, so make sure you solve it all completely. Now, number 2 is a multiple choice. So that's easy. I can narrow things down. I can use Desmos to help me. I don't have to show any work for these, and you will not have to show work on the test either. So as you go through it, number of complex zeros. All right, so I look, I know I have a cube, so automatically that crosses out D. There's 4 there. And now I just got to figure out, well, what are the zeros? Again, I can use Desmos to help me out with that. So I'm going to pull it over. Here's the graph of it. I can see one of them is -1, so that helps me. Okay, so unfortunately, all of these have a -1, so that doesn't help me anywhere. I'm going to have to get to a point where I can factor it, so I can then choose which one it would be, because they're all going to have imaginary numbers. But that's okay. I'm going to use that -1 to help me. You can choose to either, you can choose to either factor this or do your synthetic division. Doesn't matter which one you choose. That is actually pretty simple to factor. You can simply just do grouping there. But if you want to continue with your factoring, with your synthetic division, you get to this point. So we have x plus 1 and x squared plus 4, which right away I can see it's b. And if I wanted to continue going through, I would then be able to find my zeros were a 2i and a negative 2i along with that negative 1. Okay, but because it's multiple choice, you don't have to show all the work. You just have to be able to get to a point that you can choose which of those remaining values would make sense. All right, so number 3, again, another one, x squared plus x minus 6. You can use the graph to help you out, but that's a really easy one as well. Again, I know I have 2, so I can clearly cross out b. And then, again, this is an easy one to factor. Factors of negative 6 that add to 1 are an x plus 3 and an x minus 2. So I know my answer is going to be D. If you want to use the graph to help you out, there it is. I can clearly see my zeros, negative 3, positive 2, and I can use that again to get my answer. Okay. Number 4, just like the first one, now I got to do a little bit of extra work here. So I'm going to ask you how many zeros. So clearly there's 4. I'm going to pull up my graph. And here's my graph. I can only see 2 of them, negative 2 and positive 2. So that tells me that there are 2 real and 2 imaginary. I don't believe I asked you for the breakdown. I think you only have to write the total possible, but just so you're aware of what they are. Again, from there, from the graph, I was able to get negative 2 and positive 2. I'm going to use that. You could actually factor this, again, pretty easily without having to go through the synthetic division. Factors of negative 20 that add to 1 would be an x squared plus 5 and an x squared minus 4. So you don't have to always use synthetic division if you notice your numbers are easy enough to do factoring with. And again, from here, I can solve each of these. X squared plus 5 equals 0. X squared equals negative 5. When you square root, you have the square root of a negative 5, which is plus or minus I radical 5. And again, we know the x squared plus 4, minus 4 is where we're going to get our plus or minus 2 from. That's because the square root of 4 is 2. And those would be your 4 answers. Okay, so you will have 4 questions just like that on the test. Okay, then we're going to get into multiplying out. So coming up with our polynomials. These are going to take a little bit longer. Unfortunately, you can't use Desmos to help narrow you out like we did in the previous ones. So you do have to go through the process and your multiplication for each of these. There is no shortcut, unfortunately, for your multiple choice ones. So we're starting out pretty simple. Whole values, integers. Remember, they come from the opposite. So x minus 5, x minus 4, x plus 4. And then it's just a matter of however you multiply them out. So I'm actually going to multiply out the last 2. This is pretty easy. X minus 4 times x plus 4, that's the difference of 2 squares, to x squared minus 16. Distribute. And then you would simply put it into its standard form. So the function f of x is x cubed minus 5x squared minus 16x plus 80. Oops. There we go. All right, so for number 6. So for number 6, we have 0, negative 3, negative 1, negative I. You also have to remember to have your positive I. So you would do the same thing. 0, if you want to write x plus 0, you could, but it's just simply an x there. The other ones would be x plus 3, x plus 1, x plus I, and x minus I. Now, I'm not going to go through the entire process of your multiplication here, but x is just x. You can multiply these out. And then when you multiply the back end, you have x squared minus I squared. Remember, you group the like terms together. And you want to remember I squared equals negative 1. So this actually becomes x squared plus 1. And then you would multiply that out in full detail. You are going to get b as your solution for that problem. Okay, number 7. Same process. I have a -5. I have a 1 minus I, which means I also have a 1 plus I. Do not forget your conjugates. That's only when you have radicals or imaginary numbers, complex numbers. Remember, when you set up your grouping, you go based off of the integer, right? So it's a positive one, so that's why you see I have x minus 1 here. When I go through and I multiply these out, you are going to group together your whole value with your x, or your integer value, I should say, with your x. So x minus 1 squared minus, and then just like before, an I times an I is I squared. Again, you would multiply that out. So x minus 1 squared, you would FOIL it. An I squared, remember, is a -1. So this is actually a +1 at the end. So we get 1 plus 1 is a 2. Again, from here, distribute out, multiply it, and then combine your like terms. Just watch your signs as you're doing all this. And we get x cubed plus 3x squared, excuse me, minus 8x plus 10. Okay, and obviously any ones that do not have multiple choice, you will have to show work for, so be prepared to do all of that. All right, and the last one here, number 8. So you have -5 and then -3 plus radical 2. So I also have a -3 minus a radical 2. Okay, so again, when I go through and I set this all up, -5 comes from x plus 5. Now I have a -3 plus radical 2, so it's going to become an x plus 3. You change the sign of your integer value. Okay, so I have 1 plus and 1 minus. I'm going to do the same grouping along with that I did with the previous problem. So the x plus 3's get grouped together because they're identical. And then I'm going to group together the radical 2's on their end because they're identical. And again, your groupings are going to square because you're multiplying them out twice. And when you multiply all that out, x plus 3 squared is x squared plus 6x plus 9 minus a 2. And then you would go through, multiply all of that out. You do end up with C. I'm not going to go through the whole process, but that is your final answer for that one. Now, the last two, your word problems. Number 9 is an estimate. We haven't taken a look at really estimating problems. All of our answers have been nice whole numbers. So I want you to focus on this question and how I'm going to explain it to you. It is simply going to be using Desmos because you're going to estimate the result that you see. Okay, you're going to have a question exactly like this, just different storyline on the test. So they're telling us the population is 72,000 people, or 722,000 people. They also tell you we measure in thousands. So this is actually the number 722 we want to be focused on. So be aware of measurements. So this is your P, because that's the population, equals that crazy looking formula. Now remember, when we put this in Desmos, you have to use X's. So it's up to you if you want to change them first, but T is representing time in years. We know we're going to subtract that 722, so we can have it equal to 0. When we subtract those, 243 minus 722 is minus 749. Now I'm going to just simply put that in my Desmos calculator. And here we go. So there's my equation down here. I see nothing. Doesn't mean that there is no root. It means start scrolling out. So scroll, scroll, scroll. You're going to see something somewhere. Oh, there we go. So all the way over here, I have this value, 67.922. That is a root. I know I should have 3 of them because it's a cubic. If I only see 1, because I was scrolling out the same space, I can keep scrolling out. There's nothing else there. It is only that one. That is going to be my estimate because the other 2 has to be imaginary. So at 67.922, that is the solution to the problem that I had. So I'm going to write down that number. Okay, so again, from the graph, X was 69.922, and we're estimating. So this is technically about 68 years, because remember the time was in years. So in about 68 years, it took to get to that population, but the years is years since 1890. So the time that it happens at, you're going to take 1890 and add 68 years to it, and you end up with the year 1958 is the year the population met. It was 722,000 people. Okay, so just be aware, not always do you have to add your answer to something, but if it's time since a certain time frame that they told you, like 1890, you do have to add it in that case. If they just said, how long does it take? Well, it takes 68 years for that to happen. But the 68 years brings us to 1958. Okay, and the very last question, we've done one like this before. Excuse me. So we have a volume of a cube. The cube is an x minus 3 length with height. Total volume is 8. So it's broken down into 4 parts. You have to do all 4 parts. So part A says, come up with a polynomial that you can use to solve for x. So volume is length times width times height. I know the volume is 8. And I know my length, width, and height is all x minus 3. To save some time, you would multiply all of that out, and you end up with x cubed minus 6x squared. Oops. X cubed minus 9x squared, sorry. Plus 27x minus 27. And that whole thing equals 8. You move the 8 over, and this would be your function. So that's the answer to part A. That's the equation you would use. Then it says identify the possible rational roots. So that's bringing back our rational root theorem. Rational root theorem is the factors of your constant, P over Q, Q being your leading coefficient. So it's plus or minus the factors of a negative 35 all over a 1. Okay. This is fairly simple. Factors of 35 are only 1, 5, 7, and 35, and it's plus or minus all of those. So those are your possible solutions. And then it wants you to use synthetic division to show no other real solutions exist. So that's the important part. Show that there's imaginary solutions is what they want you to get to. So when I graph this, bring back Desmos. Here's the graph of that equation. I can see it crosses at 5, so there's my one real solution. And that's great. I want to use that. But I have to use it to show nothing else exists. So we're going to use our synthetic division. Back to our function that we were using. Bring down the 1, 5, negative 4, negative 27, 35, 0. There we go. And we know that 5 comes from x minus 5. 1, negative 4, and 7 is x squared minus 4x plus 7. And to prove that this doesn't have any other real solutions, we have to find the discriminant. Discriminant, again, is b squared minus 4ac. So we use the values that we have. And you would find that your discriminant ends up being a negative 12. Because it's a negative discriminant, this proves that I have imaginary values. Oops. Or imaginary solutions. So this does not give us any more real ones other than the 5 that we have. And then the last thing to do is answer the question, what are the dimensions of the cube? Well, if each side is x minus 3, and we know it's 5 minus 3, we know x has to be, we know the side has to be 2. So the length is 2, the width is 2, the height is 2. Or you can write it this way, 2 by 2 by 2 centimeters. And that is your part D. But the important thing in this is, yes, you're going to get 5 from the graph. You'd be able to find your sides right away. But the important thing is part C, being able to prove that there are no other real solutions out there, and use that discriminant, use your synthetic division to help prove that. Okay, so hopefully this review helps you out.